In this lecture, we're going to look at the handling of exceptions within our program. We've already seen that we can throw exceptions and create exception objects when we've enforced preconditions. But now we want to look at how do we handle exceptions and what are other type of exceptions that can be thrown within our program. So we'll look at what happens if, for example, a user enters an alphabetic character instead of a number, if we're unable to open or create a file, or we attempt to access an array list index that's not a valid index. So this leads to the idea of exception handling. So let's define some terminology here. An exception is just a problem, which is an error that occurs during the execution of a program, and it's often outside the control of the program. In other words, it's something that's caused by the user interacting with the program. For example, the user entered a number instead of an alphabetic character. The handling then is just dealing with the problem instead of letting the program just crash. Our motivation in this is to make programs more robust. So they're more fault tolerant, they're going to deal with errors as they occur, and then we're going to recover from the problem and then continue on executing by usually guiding the user to correct what they have done incorrectly. I want to say that exceptions are not the use of if statements, even though we have used if statements to check for an invalid condition and then throwing an exception, but the exception itself is not just an if statement. They should be used to handle problems that do not occur frequently. We're not expecting these type of problems to occur a lot, but we need a mechanism to be able to handle these problems when they do occur. And they are a special mechanism provided by language to help provide consistency and clarity in handling the problems that may occur when our program is executing and the user is interacting with it. So we can look at some example exceptions that could occur. For example, we may have an index out of bounds. There could be a division by 0. We could have input or output exceptions. We could have out of memory exception. When an exception occurs, the Java virtual machine will create an exception object. And this is going to hold information about the problem. Now we worked through the instance where we actually created the exception object when we checked in our code that there could be a problem. For example, there was an illegal argument exception. So we can create the exception object and throw that ourselves. Or in a lot of instances, if you're using some of the Java API classes, the Java virtual machine will create the exception object and throw that. That exception can then be caught and dealt with so the program can continue on. Now, some exception terminology. We're going to see the word try, throw, and catch. So try is a block of code that may generate an exception. Now, exception can be generated whether we put a try block in or not, but it means that we're going to try to put in some mechanism to be able to handle that exception. Throw is when an exception occurs and it's actually thrown up to be dealt with. And then catch is a block of code that catches the thrown exception and handles it. So the try block is a block of code where we are expecting an exception could occur that then we want to deal with in our code. So I've got an example here. We set up a scanner object where we want to then enter the number of students. That's going to be a number that's entered. So this input.nextInt is a method that can throw an exception, because then we want to be able to handle that within our code. We're going to put a try block around that. Then to be able to deal with that exception within our code, we add a catch block. And this is a block of code that catches the specific exception that has been thrown and then executes the code within that particular block. So with that nextInt method, if the user entered an alphabetic character instead of a number, it would create an input mismatch exception object and then throw that, and then this handler here, this catch statement, would catch that and then it would execute this user input error. Let's look at some example execution to help clarify this. So if I bring up Eclipse, I have some code here. And let me go ahead and run this. It's just a simple thing where I enter two values and then I divide them. So I can say enter val 1, 3, enter val 2. This is integer arithmetic. It's going to say the result of this integer division is 1. Now let me go ahead and run this again and enter val 1. Let's say I put AB in here instead of a number. what happens when this line of code here executed, it says, I'm trying to read in an integer, but the only thing I have is an alphabetic character. So that's an input mismatch exception. The Java virtual machine then created an input mismatch exception object, and it threw that up. Now, because we didn't have any handler code in here to catch this, it was then thrown up to the method they call the main method, which would actually been the Java virtual machine in this case. And so then it action when catching that exception is that it printed out the name of the exception and printed out the call stack for this. Now I can show you there are other types of exceptions that can be thrown. Let me run this again. Let's say val1 is 4. Let's say now we're going to divide by 0, do an integer and division. Notice here we get an arithmetic exception, which is a division by 0. Again, that occurred when we hit this line here. Notice once that exception was created, it skipped over this line of code as that was immediately thrown up to try to be caught. Now let's say I want to actually try to handle these exceptions. So I can add a try block. And these are the lines of code where my exception can occur. So that means I'm now wanting to be able to try to catch these exceptions. So now I'm going to put in a catch. And I got to determine what type of exception I'm going to try to catch. Now I can just catch a general exception. Every exception class is the descendant of the exception class. So I could just say EX and just put in here, just print out a message, system.out.println. Let's see, an exception occurred. So what I have now done is I've added a try block. That means there's an exception that could occur in this code that I want to deal with. So I'm going to try that, and then I've associated a catch block with that try block. Now when I run this same program, enter val1, let's say I put in AB, what it does when it hits that, the exception occurred, but now it throws it up and it is now caught by this catch handler here, and then it executes the code here. Notice that when that exception occurred, it skipped over all this code here and went straight down to the catch block. Let me try one other example where I do that division by 0 again. So enter val1, 3 divided by 0. Again, an arithmetic exception was thrown, but it is a type exception, so I caught that and just printed out this message. Now I can actually catch specific type of exception, so I can put input mismatch exception. Let me get that and put that in there, and then I can try to catch an arithmetic exception. So I change the message up here. Please enter, let's see, a number. So I can have now multiple handlers, and so system.out.println, you cannot divide by 0. All right, so let me fix any compilation errors I have. So this now all arithmetic exception. I need to give it a variable name, and I need to, all right. Let me run the program. Now I have specific exception handlers associated with the type of exceptions that could be thrown in this code up here within this try block. So I will execute the code, enter a val. Notice here, if I just enter 3 and 2, everything runs. So it runs that line of code. Everything works as expected, and it doesn't run these catch handlers. If I run this again, enter val1, I put in AB. What it does, it threw an exception of type input mismatch exception, so it skipped over these lines of code here, and then it came down and ran this exception handler here that says please enter a number. Once it does that, it skips over the next exception handler and runs the next line of code after that, which then just exits the program in this particular instance. If I run this again, let's say 3 divided by 0. At this particular point, we're trying to divide by 0, so the Java virtual machine created an arithmetic exception, which was then thrown. It skipped over this catch handler. It was then handled by this catch block where we print out this particular message. And then it drops out to the next line of code after this, which in this instance just ends up exiting the main method so the program finishes. So that's an example of seeing how exceptions can be caught within a program using a try-catch. Please note that in this particular instance, even if I came in here and removed these try-catch blocks, and then I ran this same code, the exceptions are still going to be generated. If I put in there A, it's just exceptions generated and it's thrown up. It's just we have no mechanism to handle it. So the purpose of the try-catch then is that we want to handle that within our code. So how do I know what exceptions may be thrown by the various classes that I'm using? We can actually use the Java API. And if I come up here, I've got the scanner class. And if we come down to a particular method, like here are the constructors for the scanner, you'll see in here in the documentation, here's a scanner, here's a constructor. There's actually 4 methods that can throw an exception. There's a throws that says it can throw a file not found exception. Down here, scanner constructor is overloaded. It can throw a file not found and an illegal argument exception. So that's how we know what exceptions the various classes that the Java API provides throws. Of course, we can write our own code that throws exceptions and then throw our own exceptions as we've done in checking the preconditions. So we should add a throws to our Java documentation header. We can use these exceptions to help guide the user instead of letting our program crash by throwing it all the way up the call stack. So this is where we'll have our try catch, and we're going to catch our specific type of exception. So what I have here is some example code of how we can use exception handling to help guide the user to correct any data that they may have entered incorrectly that caused the exception to be thrown. So here I've got some example code that says enter number of students. I read in that students from my scanner object here. If the user entered like a double value or an alphabetic character when they needed to enter an integer, what would happen? An input mismatch exception would be thrown at that point. These 2 lines of code would be skipped over. It would come down here. It would print out this message, input error, re-enter value. It would come back up, loop again, ask them to enter the number of students again. Let's say this time they entered a valid integer. If they do, then it comes down here. It prints out what the value is. Now it sets loop to false. Because an exception was not thrown, it comes back down, hits the bottom of the while loop, comes up, says while false, it drops out of the while loop. So that's how we can actually then use exception handling to help guide our user to enter correct data to be able to use the program. Now, as I demonstrated, it is possible to have multiple catch blocks. You must put your most specific catch blocks first, and then your more general. And this is going to be based on the class hierarchy, and you can look at page 549 in the book to see that. Remember that the first block that catches the exception is the one that's run, and then execution continues after the first line of code after the last catch block. So here's an example of using multiple catch blocks. Here's my try, here's my catch, number format, catch, arithmetic exception. Let's say down here line A has thrown a number format exception. What it does, it skips line B and C. It comes down here, the number format exception is caught by this handler. It's going to execute the lines of code in here. After it's done there, it's going to skip all the way down and execute line D. Let's say that line B, we have another execution of this program, throws an arithmetic exception. What it does, it skips line C. It comes down here. Does this match? No. Does this match? Yes, it does. So then it's going to execute the lines of code in here and then come down and execute line B. If it comes through here on an execution and it successfully executes line A, line B, and line C, then it's going to just skip over all these catch blocks and come down here and execute line D. Let's say it throws an exception in line B here that's not a number format and not an arithmetic exception. What it then does is it's going to throw that exception up to the method that called it. Now in this particular instance, we have a try catch block. This is all syntactically correct, but there's an error in this code, and this has to do with our class hierarchy, is that we have a more general exception occurring before a more specific exception. So this code here is not going to even compile. To fix this, we have to move this catch block here up in front of the catch statement for the general exception. The reason is if I threw an arithmetic exception, when it comes down here, well, because an arithmetic exception is an exception, it's going to always be caught here, so this code would never be reached. So the Java compiler won't even let you compile this. You actually have to fix this and get these handlers in the correct order. Now the finally block, so we can have a try, a catch, and then a finally block. That code there is executed no matter what. It's going to be executed if in your try block everything worked out correctly. It's going to be executed if in your try block there was an exception thrown and that exception was caught by a catch handler. Then it's going to go execute in the finally block. So no matter what, code in the finally block will always be executed. So here's some example format. We have our try, our exception types that we're catching, and then the finally has got to be the last block if we're going to add it. And these statements here will be executed no matter what. So if there is no exception thrown, after this block of code runs, it will come down here, run these lines of code, then to the rest of the code. If we come up here, there is an exception thrown. If it was handled by this catch block here, after it handles that, it then comes here and executes these finally statements, and then the rest of the code. Let's say that an exception is thrown up here that's not caught by either one of these statements are going to be executed, then it's going to be thrown up to the calling method. Now what information do we commonly print out in the catch block? We usually print out some type of information to guide the user. This information can be our own message that we come up with, or it could be information contained within an exception object. The exception object does have several methods available with it that can be used. A couple useful methods are the print stack trace method or the get message, which will print out some meaningful information regarding the exception that has occurred. So here's an example of using these. I've caught my exception object. Here's the local variable that's going to represent that object within these blocks of code. So I can say ex.print stack trace. I can print line ex.getMessage. Now, the propagation of exceptions, as I have said earlier, if a thrown exception is not caught by one of the catch blocks, then that exception is sent up to the method that called the particular method that you're in. If it's not caught there, then it's set up to the method that called it. And it will continue to go up the calling chain, or what we call the call stack, until it is finally caught, or until it finally reaches the main method. When it catches it, it then throws it up to the Java runtime environment, which will print out the default message. We have seen how we can create our own exception objects and throw them, but for these other ones that are handled by the Java API, the throwing of that exception automatically occurs when that exception happens. And if the exception is not caught, it is then thrown up. Now there are two types of exceptions. There are checked exceptions and unchecked exceptions. All checked exceptions must be handled. In other words, you're going to have a statement in a try catch block to handle that. If you do not, then it has to be thrown up the calling chain. But to signify that, you're going to have to add a throws clause in there. So when a user has a method that does not catch a checked exception, to indicate that that method's not going to handle it, it says, yes, I know there's a checked exception, but I don't want to handle it there. You then use the throws clause. So this is how you use it. We'll come in here and say for each one of these methods, all IO exceptions are checked exceptions. So we have some code down here that has some IO statements in method 2. Because they're checked exceptions, I either have to have a try catch block here to handle it, or I'm going to say, I know that it can throw a checked exception. I don't want to deal with it here. I want to throw it up to whoever called me. So to signify that, we have to add the throws IO exception. Now here what we have for method 1, we say, I don't want to handle it, so I'm going to say throws IO exception. And then the main method says, I'm not going to handle it either, so I want to throw it up. In this instance, it would be thrown to the Java virtual machine. Now, this was just an example given to show you how we can use the throws IO exception, but typically we don't want to throw it up too many levels. We eventually want to catch it and deal with what that checked exception. Way of reminder, checked exceptions must be dealt with by either catching the exception or passing the buck. And that means throwing the exception to the calling method so it can deal with it. And to signify that, we have to add the throws and then whatever checked exception we're throwing up. The last thing that I want to mention here is that there are two different types of output. We've been using system.out a lot, and that's just for general output. There's also something called system.err for error output. Typically, they're both sent out to the console or what we call the terminal screen, but sometimes we may want to send out just our standard output to the system.out and then any error or exception output to the system.err. And the reason that we do this is that we could take all our system.err output and redirect that to a file to capture any error or exception data that occurred as we are executing our program. Then we could come back and analyze that. So that's a quick overview of exception handling and how we can incorporate that in our program. You'll get some more exposure to that through the readings and then practice with it in the assignment for this week.